This is number 8 in section 2.1. It says use a calculator to graph the quadratic equation y equals 2 times the quantity x minus 3 squared. Okay, and so I've just entered this function in y1. I'm going to adjust my viewing window to match this given window of the grid. And so I'm going to adjust my window to be from -4 to 14 for my x min and x max, and from -8 to 40 for my y min and y max. Okay, and then select graph. Okay, and it's pretty easy to tell where the x-intercept is located. You can just kind of count the tick marks on the x-axis and it looks like it's at 3. But you can also look at the equation and see where that 3 is located in that binomial. I do need one other point, and the y-intercept would be pretty handy to have. And so I'm just going to select the trace button and then type 0 and hit enter, and the y-intercept, or really if I wanted to know another point, I could use the same steps, just enter an x coordinate and get the corresponding y value. Okay, one other option is to go to the table, so second graph, and you have a lot of different ordered pairs. Okay, so then I just try to replicate that graph on this given grid. Okay, B, it says use the graph to find two solutions for the equation 2 times x minus 3 squared is equal to 18. You could think about this as y equals 18, right? And so I can go to my graph that I just drew, locate where y equals 18 is, and determine where those intersections are. And so I'm just going to look down to the x-axis, and I see that one of them occurs when x is 0 and the other is when x is 6. So those are my answers. Okay, if you had a hard time determining the intersections from your graph, you can go back to your calculator in y2, enter 18 and then hit graph, and now use the intersect feature. So under second, trace, intersect, which is number 5, and then hit enter 3 times. Okay, and so here it is. So 6 is one of the answers. And you would do that again to find the other intersection.